Hello, welcome to checkpoint 3.13. They want us to find the equation of the osculating circle of the curve defined by, it says vector valued function, but this looks like a regular function. So let's say that the instructions might be a little bit incorrect there and just talking about a regular function. The function is y is equal to 2x squared minus 4x plus 5. And they want us to find the osculating circle at x is equal to 1. Alright, this is a parabola. It'd probably be nice to get a picture of this and to see what it is we're looking for. I think this picture part is optional, but it would be a good idea. Let's see. It's a parabola. I think to graph parabolas, if you remember, I think it'd be nice to put it in the standard form where you can find the vertex. So let's take a 2 out of the axis and let's leave a little space there, and we will add and subtract a term that would make this into a perfect square. So the thing that we would add would be 1, but we're not really just adding 1, we're adding a 2. And if we add a 2 on the same side, we'll also subtract a 2. And that'll give us 5 minus 2 is 3. So this will give us a 2 completed square. It's going to be x minus 1 quantity squared and a 3. So it looks like our center is going to be at 1, 3, which is actually good news, because if it's going to be a vertex, it's going to be, this is opening upward at 1, 3. So it's opening upward from here. We can even find the y-intercept by setting x is equal to 0. So when x is equal to 0, this is 2 times 1 plus 3 is 5. So we're going to hit the axis at 5. So your parabola will look something like that. And at x is equal to 1, you can see that the y value is equal to 3, and we're going to draw a circle here that's going to be just tangent to that. So that looks like it's going to be a fairly small circle. But what is important here is that since this is a minimum, your tangent vector would be horizontal, which means your normal vector would be going straight up. And so I guess there was an advantage of drawing this graph that helps us find our normal vector. So your normal vector is just going to go in the j direction. Let's call it 0, 1, but let's say 0, 1. But that's going to make things easy for us, because now we just have to go a certain height from 1. So the center of the circle is going to be 1 comma something, and the something will depend on the curvature, and the radius of the circle is going to be 1/2 of the curvature. So let's go ahead and find the curvature. That would be kappa of x. I think we need a couple of things. If you remember, the formula for kappa of x is the second derivative, and 1 plus the first derivative quantity squared, or the first derivative, just the first derivative quantity, first derivative squared, and then the whole thing taken to the 3/2 power. Alright, we need some stuff from our original function. We need our first derivative, and that's going to give us 4x minus 4, and our second derivative is constant, and that's going to give us our kappa. Kappa for this function is going to give us a second derivative up on top, so that's a 4 divided by 1 plus 4x minus 4 quantity squared raised to the 3/2 power. Now if we put 1 in there, as they're asking for, this is going to give us 4 divided by 1 minus, and this is going to be 4 minus 4. And that's just going to be a curvature of 4. So down here we're going to have a curvature of 4. And with parabolas, if you remember, the vertex is going to be the largest curvature. And being that it's the largest curvature, your radius for your osculating circle is going to be 1 over the curvature. So we're going to have a small radius of 1/4. Okay, so now let's take a look at the geometry of this. We have 1/4. Your center is going to be just the radius away from 3. So your center will be 1, 3 plus the radius. We can call that, what is that? 12 plus 1 is 13/4. So your center is going to be 1, 13 divided by 4. Okay. And with that, we have the center of the circle and we have the radius of the circle. So we put it together. We have the equation of the circle. So osculating circle will be given by the equation x minus 1 quantity squared plus y minus 13/4 quantity squared is equal to 1/4 squared for the radius. Okay, and that should be it. It might be nice if you can put this on Desmos, just graph this in Desmos and graph this in Desmos, and then see, and then zoom in to see a picture that looks something like this, without the arrows, unless you draw the arrows too. Okay, enjoy it.